All right, check, check, mic check, and we're live. Testing audio.
All right, check, check.
All right, it's a little bit loud.
Testing audio. All right, check, check.
What about this? Check, check. All right, can you guys hear me? Hey, Crystal. How's it going? Seth, welcome in. Crystal, welcome in. Jackson, welcome in. Testing audio. What's up, everyone? Good to be here. All right, I think the audio should be good. Let me know if the music is too loud. We're gonna do some calculus today. Oh, perfect, you read my mind. Okay, integration by parts. Sounds like a plan. Let me get the poll up and then we'll get started right away. Integration by parts is fantastic suggestion. Let's get started. Let's get 40 minutes on the clock. Only 4 votes today, only 2 votes today. Are you done with the finals? A, yes. B, no. All right. So we got 40 minutes on the clock. I'm sure there's gonna be a bunch of trolls that select C, D, E, but if you select A, you're done. B, you're not done yet. And C, that I'm gonna assume C means you're not taking finals. Okay, so let me just do current topic is calculus. Current subject is calculus. And then current topic is gonna be integration by parts. Integration by parts. All right, and anyone that is just joining in, welcome into the chat. We are just getting started. We're gonna jump right into it. Integration by parts. How's everyone doing? Eam says A. B, next semester might cook me. What are you taking next semester, my friend? Why do you think you're gonna get cooked? Remember, don't get cooked. You're gonna cook the semester. Don't get cooked. So we're gonna do integration by parts. Integration by parts. And this is one of my favorite topics to teach in calculus. I say that a lot. Okay, don't get me wrong. I say that a lot. But this one in particular, because this has a famous movie scene in my favorite movie called Stand and Deliver. And we're going to do that integral in that movie scene. I'm doing great, Elise. How's it going? I got an A in Calc 1. Awesome. GG's. B in Orgo is amazing too. W. Calculus-based physics 1, chemistry 2, calculus 2, data analysis, chem 1 and 2. Okay. That is a little bit heavy, but don't get cooked. Don't get stressed out. Just lock in. All right. So suppose we have the integral. It's going to be, let's start off with x squared e to the x. All right. So x squared e to the x. Let me make this a little bit bigger, or you can rotate your phone so you can view it on your horizontally. And as usual, I highly recommend you actually follow along and get out some notes. Maybe school is the last thing on your mind right now, but it's highly suggested so you can retain the information. Okay, and right now we're gonna do, suppose we do a U sub. Well, we're gonna run into a problem. If we try U sub, it's not going to work because, for instance, try U equals x squared, then du would be 2x dx, and we would not be able to integrate. Got an A in 1. Physics 1 just reviewed the derivatives. Theory's the same. Thanks for that. So it's not going to work, so we need a new formula, which is called the formula for integration by parts, and is given by, we select a u and a dv, and the formula is going to be uv minus integral v du. Okay, and the way you memorize this is you're gonna say ultraviolet voodoo, ultraviolet voodoo, ultraviolet voodoo. Okay, so this is gonna be the formula to memorize integration by parts. I think I'll learn this at the beginning of Calc 2. Yes, most likely in the beginning or middle of Calculus 2. And then series, yep. Okay, so how do we do this integral, chat? Guys, welcome into the chat. We are doing integration by parts currently. Feel free to drop me your questions down below. And we're gonna select a u, okay, such that it's something that is easily differentiable, and a dv that is not any worse when you integrate it. That's the way my professor taught me, and that took me forever to understand. But we're gonna select u to be x squared, and then you're gonna put a u right over here, and we're gonna select it to be x squared. And the reason we know it's integration by parts is because we have a function times another function. Okay, we have a function u times a function v. Then we will select our dv term to be the other function, which is e to the x, because e to the x is easily integratable. All right, so then we have to differentiate u with respect to x. Chat, go ahead and let me know what's the derivative of u with respect to x, and what is the integral of dv with respect to e with respect to x. All right, someone already answered that one, e to the x. Okay, why is u x squared? Because, as we'll see from this formula, it's going to be differentiable. It's an easy function to differentiate. Okay, so I see two functions. Let me highlight this one in, let's say, blue, and this one in green. So this u function is the easy function to differentiate, and this function is the easy function to integrate. So the derivative of u is 2x dx. All right, and the integral of e to the x is e to the x. Perfect. Let me take a pause here. Let me know if there's any questions here so far. And guys and gals, hope everyone's doing amazing. We are just getting started with our first problem. Okay, I see no questions, so I'm going to continue on. So uv is x squared, okay, times e to the x, okay, because that was a u times a v, okay, minus integral, okay, e to the x v integral, I'm using the formula e to the x du is now, our du is now a 2x times dx. Okay, so the only problem here is now we have an integral inside of an integral. So we just did an integral, we have another integral. But not to worry, because, well, we can do the formula again. Okay, so instead of doing that, I have a trick for you. And someone commented down below is the DI method. So instead of doing that, I encourage you to continue from here. You select u to be a 2x and a dv to once again be e to the x. So rather than that, check this out, I have a lovely trick for y'all. We're gonna do what's called in calculus terms, it's called the tabular method, but I call it the tic-tac-toe method, as made famous by Stand and Deliver, the movie Stand and Deliver, which I highly recommend. Here you're gonna select your u, and here you're gonna put your dv. Okay, so our u is not gonna change. It's still gonna be x squared. It's still gonna be x squared over here. Okay, and then our dv is still gonna be our e to the x. Okay, but on the left hand side you're going to differentiate. Okay, and on the right hand side you're going to integrate until you get 0. Okay, so we're gonna go ahead and differentiate the left hand side. So chat, let me know what is the integral of x squared. What is the what is the derivative of x squared rather? What is the derivative of x squared? It's gonna be 2x, and then what's the derivative of 2x, and then what's the derivative of that? Okay, so what's the derivative of 2x is gonna be 2, and the derivative of that is gonna be 0. So now we stop. Okay, so we stop at 0. So the left hand side, okay, on the left hand side you keep going until you get 0 for the derivative. Exactly, there you go, Christelle. Okay, boom, got it. So we get x squared 2x 2 0. On the right hand side we just keep integrating until we get that. And so this is a really common first example because integral of e to the x is just e to the x. And then we alternate signs. Okay, so we start with a positive. We alternate signs. So do positive, and then you do a negative. You're gonna tack that on. Positive, negative, and then you're gonna stop at 0. Okay, and then the magic sauce is again made famous by the movie Tic Tac Toe. And just like magic, we have our answer where we avoided doing a multiple integral series. We get the answer where we multiply x squared times e to the x minus, okay, because I did x squared times e to the x minus a 2x times e to the x minus a 2x times e to the x plus another 2 times e to the x. And this is a boundless integral, so we have to add the integration constant, which is plus c. All right, and that's the beauty of this particular integral. Technically, we could factor out the e to the x, so let's just factor out that. So we have e to the x plus times x squared minus 2x plus 2, okay, plus c. And there we have it. That's our lovely first integral for today. Ultraviolet voodoo, chat. Ultraviolet voodoo. Okay. And beautiful. We have our first problem for today. So what I'm going to go ahead and do is screenshot that and drop it into Discord right after this. Guys and gals, let me know if we should do another example for this or another topic. Anyone that's just joining into the chat, my name is Dr. Drew. I go live every single week to answer your STEM questions. And first topic was calculus, integration by parts. My question for y'all is, are you done with finals? Select by tapping the vote on the screen. A for yes, B for no. And guys, the next question is, do we do another example for IBP or should we do a different topic altogether? Let me know. I just got flashbacks. It's winter break. I know, probably calculus is the last thing on some of your minds, but here we are. Crystal says another good example. Let's do it. All right. Secret account. All right, so let's do another example. It's going to be, let's see. So I'm going to think of a function here, unless I find one here in the chat. And this one's going to be cosine of x times something. All right, I think, let me see if my book has one real quick. Final chem just killed me. Oh no, Sin. How did it go in chem? Can you do an easy one about series? All right, Eam, you're going to be next for series. Sounds good, my friend. We're going to do series next. Of course, plan B. It's my pleasure. Glad to be here. Also, chemical engineering major. I'm trying to stay positive. All right, you got to join the Discord, my friend. Guys, while I pull up this next example, let me just advertise the Discord real quick. You can join the community of engineers and STEM lovers. Just go to engineeringminds.co and tap that link that says Discord. Guys and gals, anyone that's already in the Discord, can you do me a big favor and just vouch for me? Like, isn't it an amazing Discord? Because we do free homework help and live streams and tutorials. So as a fellow chemical engineer, yeah, you definitely want to join. And you can join by tapping the link in bio and then tapping that link that says join for free. It's totally free. Oh, another chemi major. Okay, we got tons of chemis in the chat. Guys, you're in the right place because I'm a chemical engineering PhD. So I got my PhD in chemical engineering. But, guys, guess what? I actually was cooked in undergrad in high school. I didn't know how to study. And I still made it through. So, moral of the story is if I can make it, anyone can make it, literally. All right, so we're going to just do x times e times cosine of x. Okay, this is a pretty standard one. So once again, we're going to select our u to be something that is easily differentiable. So chat, go ahead and let me know what you think it should be. And then we're going to select another dv to be something else that is not hard to integrate. Okay? So I want you to notice that this function, this integrand, is of the form integral u times v. Integral u times v. Okay? Let's write that down in a small character here. So you can see that's integral u times v. Okay? All right, u of x dx. U of x, v of x dx. All right, so what should we set our u and what should we set our v? Okay? Have an SQL final tomorrow. What's SQL? Worth 40% of my grade. All right, Jack. We're here with you, man. I'm going to be on here for another hour. I don't know what that is, so just lock in with us. Just put me on silent. Just put me on mute. Put your phone right there so you're not distracted, but just put it on silent. All right, u equals x. Very good. Okay? So sometimes people ask me, how do you know? And see, you just answered your own question. How do you know? Because u is easily differentiable to, well, that's just going to be dx. Which means our dv is going to be cosine of x. So what's the integral of cosine, chat? What's the integral of cosine, chats? I mean, cosine of x, chat. Yes, we are doing integration by parts currently. The next topic will be series. Okay? So let me add the next topic too, so I can be fair and keep it going. We're doing lots of calc today. That's awesome. That's awesome. We haven't done much calc lately. And so perfect. So someone said the integral of cosine is sine. Okay. Intro to series. All right, so the integral of cosine is sine. All right, so that's going to be sine of x. All right, perfect. So we're going to apply the formula, which is going to be the uv minus integral v du, which again, remember the mnemonic ultraviolet voodoo. But I will not do that. I'm going to go ahead and use the tic-tac-toe method. Okay? So what I mean by tic-tac-toe method, also known as the tabular integration. So tabular integration is we're going to select our u right over here. And then our v goes right over here. And then on the left-hand side, we have x. On the right-hand side, we have cosine x. Okay? And we differentiate once, we differentiate again, we get 0. All right, and chat, go ahead and do me a favor and drop the integrals for cosine of x twice. So what's the integral of cosine of x? And then what's the integral of that? Okay? That's my final tomorrow. Then you're in the right place because that's exactly what we're doing right now. Okay, so what's the integral of cosine? So someone already said this is sine, and then so what's the integral of sine of x? What's the integral of sine of x? All right, then the next one is gonna be, all right, Nathan finished. Nathan finished, good job, Nathan. Then it's going to be negative cosine, right? Because if I differentiate cosine, I get negative sine, but we don't want negative sine, we want a positive sine, so that's why I have a negative cosine, good. All right, and then on the left-hand side, once again, we're going to differentiate. We're going to take the derivative. And then, wait, we already did that. And then we're going to do plus, minus, plus. Right-hand side, we integrate. We already did that. All right, so all we have to do is tack these on. So I'm going to do tic-tac-toe. So we only have two terms this time. So that's x times sine of x. Okay, minus of 1 times cosine of x. Okay, plus c because it's our boundless integral. Okay, and that should be the answer. That should be the answer. Optimization, I'd love to. The next topic on the list is series. So the person that asked series, please let me know if you're still here, because you'd be up next. So if you asked about series earlier, go ahead and drop a comment like okay or something. And let's see. This should be a minus minus is a plus. X times sine of x plus cosine of x. And then the next topic after that, we can do optimization. So current topic, we're going to do series. And then next topic, we're going to do optimization. All right, so that was EAM. That was EAM. And then we have 1, 2, 3. Let me write that one down. 134 over x squared dx from 2 to infinity. That's going to be our Gaussian integral. Is series as bad? Low-key, I think series is kind of bad. I think series is low-key kind of hard. but nothing is impossible, my friends. So that's why we're here. You just have to lock in. Nothing is impossible. Okay, so series is all about tests, okay? So I think I'm just gonna go ahead and give you the comparison test. Let's see. We're gonna do an intro to series. I'm gonna go ahead and just do the comparison test because that one's kind of a little bit confusing the first time you learn it. Tic-tac-toe method is so cool. Oh yeah, definitely tell your professor about it. Your professor is not gonna call it the tic-tac-toe method. Your professor is gonna call it the tabular integration. The formal term is tabular integration, but I call it tic-tac-toe, made famous by the movie Stand and Deliver. All right, so before we talk about series, I'm sure a lot of you are barely starting off Calculus 2, so let's just talk about series in general. So a series is kind of like a function in the sense that we're looking at points. So let me just pull up a series here. Let me pull up a series. So for instance, the number pi can be written as a series, okay? Let's just call it an infinite series is going to be given by a sub n. So we already kind of have an intuition for a series because of integration, right? So the sum of a sub n from n equals 1 to infinity is a series whereby this can be expanded to be what? Well, a sub n indicates an integer, so we're looking at discrete functions now. This is more of like a discrete set of values. 1, n equals 1, and then we add the next one. The next integer above that is a 2, and then after that is 3, 4, and so on. Okay? So as you can see, if n goes up to infinity, okay, then this series is going to blow up to infinity, right? So I want you to contemplate if this is going to blow up to infinity or is it going to be reduced to 0, okay? So chat, is this one infinity or negative infinity or 0? Comment down below. Is the summation of n equals 1 to infinity of a sub n a positive infinity, a negative infinity, or 0? Or a finite value? When you find the integral, you work backwards to find sine of x equals cosine of x, but backwards sine of x equals negative sine of x. Wait, sorry, sine of x equals negative cosine of x, and the derivative of cosine is normally negative sine of x. Correct. Okay, so Eam says 0. No, my friend, this would be infinity, my friend. So this is gonna blow up to infinity, okay? Because 1 plus 2 plus 3 plus 4, etc., is gonna blow up to infinity, okay? Contrarily, let's take a look at another example, okay? Well, because why? Because if you add, 3 plus 3 is 6, plus 4 is 10, plus 5 is 15, and keep following that pattern all the way into infinity, that's gonna blow up. Okay, what about another one here? This is gonna be basically 1 over 2 to the n. 1 over 2 to the n. You may not know what this one is, so the whole point of calculus 2 is to figure out what this value is. Okay? So chat, 1 over 2 to the n is something like 1 over 2 to the 1, which is 1 over 2, plus a 1 over 2 squared, plus a 1 over 2 cubed. And since this is a live stream and we're having fun here, let's go ahead and prove this one geometrically. Let's go ahead and prove what this series would be. And first, let me know your guess. Do you think that this is going to be a positive infinity, a negative infinity, 0, or an integer? Okay. I found that review properties of exponents help to evaluate the convergence and divergence test. Okay, thank you for that tip. 1, 2, 3, 4, 5, 6, 7 says you want to review your exponents and properties of exponents prior to reviewing calculus 2 because you're going to use that a lot. Thank you for that. Okay, Lex already says it converges to 1, so we're going to prove that. So 1 over 2 is half, okay? And 1 over 2 squared is a 1 over 4. So 1 half plus 1/4 is 3/4, okay? So we basically shaded 3/4 of this. And this is a geometric proof. This is not an algebraic calculus proof. This is a geometric proof. All right, so we have 1/2 plus 1 over 2 squared is 3/4. Plus 1 over 2 cubed, that's 1/8. So that's gonna look something like this. Okay, so now we're over here. So now hopefully you can see the pattern emerging. Plus 1 over 2 to the 4th is 2, 4, 8, 16. Okay, so that's gonna be this square over here. Plus, if we continue the pattern, that's gonna be 1 over 32. Okay, and if we take that sum all the way to infinity, we see that this value is actually going to be a finite value of approximately 1. Actually, not approximately, it's going to equal to 1. So that's really interesting. That's gonna serve to motivate us for Calculus 2. OMG, I love math. Welcome in. You're in the right spot. Okay. Oh, Eagle says struggling with Fourier. We can definitely do Fourier. Are you an engineering major or a math major or a physics major? Okay, so one of the series here is going to help us to prove that this value is indeed an integer value. So sometimes series can blow up to infinity. Sometimes they can diverge to negative infinity or positive infinity, or they're going to converge to a value. Okay, so if it converges to an integer value, that's called a convergence series. Okay, so our goal for all of Calculus 2 is to determine what type of series it is. Okay, that's all we're doing. It's a whole slew of different types of series. Okay, and so that's going to be convergent if it converges to a value. Ooh, chemical engineer, fellow chemical engineer. So that's gonna be the next topic, my friend. If you stick around for a bit or join the Discord, you can drop it in. Eagle, I highly suggest you drop it in the Discord and I can just help you after, my friend. Okay, and again, if you want to join the Discord, just tap that link in bio. Okay, it's totally free. Okay, so question for you, chat. Do we want to look at different series or do we want to do different tests? Okay, so question for you, because question of the day is already active. So do we want to do more series examples or do you want to do tests, which is the next part of series? So this is like an intro, and then this is like test is like what you're going to be tested on. It's like how would I say it? Test is like the main topic. So if you want to see more examples on just series, just to have an intro, you're like, hey, it's chill, we don't need to do the full test yet, it's winter break, then vote for happy face. If you want to jump right into it, vote crying emoji. Okay, just comment down below. Plan B says more series. Okay, divergence convergence is kind of like intro work for the real subject, power series. Exactly, yeah, power series are going to be some of the main ones. Okay, is series the same as Riemann sum? Technically no, but the symbol is the same. Okay, the symbol is still the same. It's the same idea, you're adding. Okay, but Riemann sums, you're getting summation, that's integration, so you're getting area under the curve. Okay, we're not doing area under the curve anymore. We're doing series now. So you're looking at integer values, not finite differential elements. Okay, so guys, do we want to do more examples? Let's just do some more examples for now, and then we'll do a couple tests. Okay, because you're gonna see this all in Calculus 2. I think I'm in Calc 1, so I think that might be Calc 2, just trying to follow along. Okay, sounds good, yeah, this is like Calc 2, guys. This is like Calculus 2. So let's just do a couple more examples of just plain old series, and then we'll do some examples of tests. Appreciate you all following along. Okay, anyone that's just joining in here, my name is Dr. Drew, and guys, I go live every single week to answer your STEM questions. Okay, and today's topic is calculus. So suppose that we know the sum of the first n terms of the series, and let's see. So another example of an infinite series is going to be called the geometric series, so you might as well start memorizing some of these. So geometric series is of the form summation, okay, ar to the n minus 1, okay, from n equals 1 to infinity. Let's rewrite this. Sum to to infinity. And so let's evaluate what this is going to be. And so r is just another like number, okay? So we're going to just leave it as is. Okay, we're going to leave it as is. So we vary n, okay? By the way, anyone that's a CS major, this is basically a for loop, by the way. Okay, so a for loop is basically you repeating many times. All right, so we're gonna leave a, and then r is also constant, and we set n to be n equals 1. So we have 1 minus 1, which is 0. So we have a r to the 0, which is just 1. Okay, so the first term is just a to the power 1. All right, then we have a times r to the power n minus 1. Now n equals 2, so 2 minus 1 is 1. So we have ar to the power 1 here, and then we keep repeating that. So then we're gonna have ar, okay, squared for n equals 3, plus ar cubed, and keep going on forever. Okay, so this is provided that a is not 0. Okay, so this is called a geometric series. All right, this is called a geometric series. And so we can evaluate different cases for different values of a and r. All right, and so let's see a couple cases here. Okay, let's see a couple cases here. If r equals 1, well, we just have all those terms equal to a to r times r to the power n minus 1 is just a plus, well, if r equals 1, that's just a plus a plus a plus a. So that's going to be equal to n times a. And then that's just going to be positive infinity. Okay? So that means the limit does not exist and it's going to diverge. All right? If r is not 1, then we plug those in. And then we're going to have that value there as well. Okay, Pi Man, imaginary numbers. We can definitely talk about that. At the moment, we're talking about series, so if you don't mind sticking around for the next 10-15 minutes, then you will be next. But we can definitely talk about imaginary numbers. So this is the geometric series. All right. And let's see if we have another example for series here. And then another example is going to be the harmonic series. Okay, so the next is going to be the harmonic series. So harmonic series is going to be given by the formula. Okay, it's basically 1 over n. Okay, so we kind of saw that value is before is 1 over n is a 1 over 1, which is a 1. Okay, so 1 plus 1 over 2 plus 1 over 3 plus 1 over 4, etc. All right? And it turns out that this one is actually divergent, which is really interesting. So there's a small proof we can do here. All right, cool. So I think I'm going to just do a check-in and see if this is a good, intuition for series here. So chat, let's do another quick poll. Do we want to keep doing here would be series, vote for happy face, or next topic, you're going to vote for a crying emoji. Okay. Just comment down below what you want to see next. I got to check who is next real quick. Chat, give me 1 sec. And I think it was basically the person that asked about Fourier. So Fourier series is particularly challenging here. Okay, so I think we're gonna move on anyway. Oh, optimization. Sin asked about optimization. There we go. Yeah, optimization. Okay, chat. So the next topic is gonna be on optimization, and if the person that asked about Fourier sticks around, we could do that. And then the next topic would be basically imaginary numbers, if that person sticks around. Okay, so it's first come, first serve, guys. So now we're gonna do optimization. All right, cool, chat. Thanks for sticking around, and hope everyone's doing lovely. My name is Dr. Drew, and yeah, hope everyone was crushing finals. this week. If you need any STEM guidance, I'm your guy. I got you for tutoring for Calc, Physics, Gen Chem, OChem. And yeah, guys, I go live every single week to answer your STEM questions, my friends. All right. So the next topic we're going to talk about is going to be optimization. And question for you, are you already kind of good at optimization, or are you totally cooked? Do you need to start from the beginning? Like, hey, I have no idea what's going on and I need to start from the beginning. Or, you know what? I get it. Let's just do some examples. What would you like to start off with? Okay. So, and by optimization, do you mean the word problems or do you mean the graphs? Eames says cooked. Okay, Eames says cooked. So, optimization, they can be kind of hard at first, but then once you get the gist of it, you're like, oh, okay, that's not that bad. Sin says the word problems. Okay, the word problems. Thanks for that. Yeah, that's what I meant to ask. Did you mean the word problems or the graphs? And you meant the word problems. Perfect. All right, cool. Totally lost. It's just about knowing the area formulas and how to manipulate them. Yeah, it's not just the area. That's one example. Okay, so here's the general overview. This is one of the most common questions I go over with my clients, by the way, for calculus. You basically need two equations. Okay. The first one is going to be your optimization function. Okay, and don't worry, we're going to do some examples. Let's do at least two examples. And then the second one is going to be your constraint equation. Okay? And then step one is basically to write those out. And then step two, let's just call that step 0. And then step 1 is to derive an expression. For equation 1. Okay? And then step 2, because once you break it down step by step, then they all become the same. It doesn't matter if it's a cylinder or an area or a triangle or a box. And then step 2 is to differentiate with respect to the variable in equation 1. And then step 3 is to basically solve and optimize. Okay? So once you understand that, then they all become the same. Because I remember I was like, oh my god, all of these are different. This one's asking about a triangle. This one's asking about a circle. I'm freaking out, and I was cooked. Okay, so we're going to start off with the area ones because that's probably the base case. And the typical example is like we have some fencing. We're going to block off a fence. Okay. And guys, I think I have some videos where we went over this on my channel, on my live streams. So after this, go to my YouTube channel, and then you can watch some more examples. Or if you can't find it, just DM me and I'll send you the link. Okay, or I'll drop it into Discord. The ones that have money, oh yeah, the ones that have money are kind of hard. Hey, Dr. Drew, can you please go over when to use different integration techniques after 48? You got it. Okay, and then by integration techniques, do you mean, okay, I'm going to assume that you mean like U sub and those kinds of things. Okay, so this one's going to be imaginary, and then we're going to do Fourier. No, I mean integration techniques. All right. And then guys, make sure you answer the question of the day. Are you already done with finals? Vote in the top left-hand side of your screen, or not yet. Okay, so we're going to do our first example. So take a screenshot of that if you haven't already. All right. And our first one is going to be a farmer. This is a really common example. I don't think you're going to have this on your final. This is going to be more like a homework example. Your final is usually like a triangle. It's almost always a triangle on your final. So we basically have a river bank. Thank you, Jackson. You're the GOAT. So this is our river. And, okay. And we have some fencing. So the problem is going to tell you, so I'm going to read the problem for you this time, but in your homework, it's going to tell you what's the constraint. So I'm going to read it for you. It says, a farmer has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. He needs no fence along the river. Hint, hint. I'm going to repeat that. A farmer has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. He needs no fence along the river. What are the dimensions of the field that has the largest area? Largest area. So I know the problem isn't on the screen, so I would highlight it. But for the sake of time, I'm just not going to highlight it today. The key words here were largest area. So that's telling us that what we're optimizing. So we're optimizing for area. And that's going to be equation 1. So chat, comment down below what the equation is going to be for that case. And the second key word was needs no fence along the river. Needs no fence along the river. So that's our constraint equation. Okay, all the problems are designed to be like this. All the problems are going to have an optimization keyword and then a constraint sentence. So this is going to tell us our constraint equation. All right, chat. So that's going to be our optimization function and then our constraint equation. So let me know what you guys think it is. Perfect. So sine says L by W for one side. All right. So we can define, now the hard part for students is always selecting the variables. So I'm going to just use X for horizontal and then Y for vertical. Okay. So I use my familiar formula. Yes, it's length times width. Yes, it's length times width, but I want to do it in terms of variables. Always use variables. X, Y, V, W, velocity, V. Once you take physics, this becomes more intuitive. If you haven't taken physics yet, I understand this is kind of hard the first time you do it, but I want you to think in terms of the variables. Don't use L times W because you're going to forget which one's your variable to differentiate, okay? AP Physics midterm tomorrow. Am I fried? JY, what's your midterm on, my friend? I hope not. I hope you're cooking it. If you're in momentum or energy, I hope you're cooking those equations. So that's our equation 1. This is our optimization function. And the thing that we're optimizing is we're trying to get maximum area. Okay? And then the constraint equation, it says we have 2,400 feet of fencing. So the constraint equation is 2,400 feet. So it's going to be X plus 2 times Y. Okay? That's the perimeter of everything except the river. X plus 2 times Y. So this is X, this is Y, this is Y. So that's our second equation. So guess what we're going to do now? So now we have 2 equations and 2 unknowns, and we're going to optimize that by plugging in equation 2 into equation 1. Michelle, thank you for the follow. Welcome in. The Real says, I'm fried for physics too. When's your guys' physics finals? Maybe tomorrow we'll do physics. Today is calculus. Maybe tomorrow we'll do physics. When's your guys' finals? Hopefully it's not tomorrow. If you come back tomorrow, we'll do some more physics, chat. So I'm going to plug equation 2 into equation 1 by subtracting both sides by 2y. So I'm going to optimize my x. So I want to solve for y here. I'm going to solve 2y equals 2,400 minus x. Technically, it doesn't matter if I solve for x or y, but that's just kind of the standard that I chose. 2,400 divided by 2 is approximately, what is that, 1,200? Okay, minus 1/2 x. Okay, so now I'm going to plug this equation into my equation 1 and then write that in terms of area. So area equals x times y, but y is now 1,200 minus 1/2 x, right? So now I'm ready to differentiate that guy. Okay, now the rest is cake, because these derivatives are usually pretty easy. So I'm not even going to do this derivative, chat. I'm not even going to solve this. Let me just double check that I got this correct. I think we should be good here. That's basically going to be a 1,200 minus x. I think we should be solid here. Okay, and then you set that equal to 0. Okay, and then guys, we're gonna do another example. So then you just set that derivative equal to 0, plug that in, and you get your answer. Okay, we're gonna do another example because I want to do a 3D one, because sometimes the 3D ones can be scary for people. Okay, but once again, if we break it down step by step, they're not that scary. So this one is going to be an oil drum. Okay, so if you're a chemical engineer, you're going to see this again in chemical engineering classes, but you're going to see a different approach. This is the calculus approach. That's the really cool thing about math, guys. If you like math, you're going to love engineering, trust me. If you like math and you love applications, you're going to love engineering. All right, so this is going to have 1 liter of oil. And then we basically want to minimize the cost. That's all it tells us. It says find the dimensions such that we minimize the cost. So there we go. We have our 2 equations. The first one's going to be the optimization function, and the second one's going to be the constraint equation. USA uni system is so different from Germany's. We just write exams. There's no midterms and stuff. Interesting. How many exams do you have in Germany per semester? Okay, so this one's going to be the formula for a cylinder. Remember, if you forget the formula for a cylinder, you can just start with the circle. So the area of the circle is pi r squared. A equals pi r squared. And then we integrate that along the height. So the volume is going to be pi r squared times delta H. Okay? Perfect. So our constraint is 1 liter. So we can't have an infinite size volume. Obviously, if we want to have the most amount of volume, it's going to be infinity. But we're constrained to 1 liter. Okay? So we need to minimize the cost of the material. So we have to add the area of 2 circles. 2 circles is pi r squared times 2. And the area of the wrapping of the can itself, the area of the exterior, which is effectively the diameter, the circumference, pi times d, times that total length, which is h. Okay? So I can't stress this enough. If you're taking calc right now and you have this on your final, you need to practice writing these out. Okay? I'm not good at these because I'm smart. I'm good at this because I've done this problem so many times now that I've helped other people that I can kind of see it in my head. But the first time you can't see it in your head, you need to write it out. I can't emphasize this enough. So the total area is the bottom area, okay, plus the top area. So that's going to be 2 times pi r squared, and then plus the entire cylinder itself. Ooh, my colors are ugly today. My coloring was terrible today. Forget about the colors. It's going to be 2 times pi r squared plus pi times diameter, which is 2 pi r times the height. Okay? So I can't emphasize. Beautiful. So now we're going to set that total area to be constrained to be, we're going to optimize this, but then our total volume has to be 1 liter. So you might say, wait, what am I supposed to differentiate? Aha, this is the key that everyone forgets. Use the constraint equation. Don't differentiate until you use the constraint equation. Okay, so the constraint equation is pi r squared h equals 1 liter. Okay, 1 liter. So now I can solve for whatever I want here. Suppose I want to solve for h here. And I solve h equals 1 over pi r squared. 1 over pi r squared. Now I plug this guy into h. Aha, now I reduce the degrees of freedom. So in engineering class, you're going to learn about degrees of freedom, which comes from mathematics. Degrees of freedom means we had too many variables, but now I reduce the degrees of freedom because I have my function now in terms of h. So now my h equals 1 over pi r squared, right? So I'm going to plug that in here. Aha, now I'm ready to differentiate. I have a of x equals 2 pi r squared plus 2 times pi times 1 over pi r squared. Okay, if you miss any part of this, if I'm going too fast, I'm gonna post this on YouTube tonight. Dory, thank you for the heart me. I'm gonna post this on my YouTube channel tonight, so don't even worry if I'm going too fast here. This is a 1,000, by the way. Apologies. This is 1,000 liters. 1000. Wait a sec. This is... Oh, this is in... Wait, they did this in centimeters. Okay, they just converted to liters, so we're just going to do this in 1000 centimeters cubed. This is 1000 centimeters cubed because we wanted that in centimeters. So we're just going to change that 1 to 1000. Perfect. So the next part is easy. All we have to do is differentiate this guy. So that's 2 pi r squared plus 2 pi r times h, which is 1000 over pi r squared. So I think you guys can take it from here. Take the derivative with respect to r now. Okay, and then solve for r. So you're going to take dA, take dA dr, set that equal to 0, and then solve for r, and then solve for h. Plug that into a 1000 over pi r squared, solve for h. Okay, let me check in with the chat. The person that asked about Fourier, my fellow chemical engineer, if you're still here and you want to go over some Fourier, I got you. Now's your turn. You're up next. Let me know. Otherwise, I'm going to skip you and then go to my friend that asked about imaginary numbers. Then you're right after Fourier. And then after imaginary will be integration techniques. So those 3 people that asked, let me know if you're still here. If you guys still have any more questions, now's the time. It's not too late. I'm still have about 25 more minutes. Anyone that's new here, welcome into the chat. My name is Dr. Drew. I go live every single week, Monday through Thursday, to answer your STEM questions. And the topic that we just went over is optimization. Hopefully that was helpful. Once again, if I was going too fast, don't worry. I'm going to post this on YouTube later tonight. And let's check in with the chat. Eagle says yes. Okay. About 5 on average. Okay. So, Sin, I kind of missed your cone one. Apologies, my friend, but hopefully this helps you anyway. If you want to drop it in the Discord, go ahead and do so. You can DM me or drop it in the Discord channel for free. Okay, so Eagle has a Fourier question here. All right. Thank you, Eagle. Appreciate you. So let me just update that. So it says, find the Fourier series of g sub x equals absolute value of sine of x over 2. Okay, for 0 to 2 pi. For 0 to 2 pi. All right. Perfect. Periodic on all the real numbers. All right, awesome, Eagle. So thanks for that. Always looking forward to help any fellow chemical engineers. And guys and gals, once again, if you need any further guidance, if you need any private tutoring for math, chemistry, physics, or organic chemistry, I got you. Can sign up for tutoring at the link in bio. All right, so all right, thank you, Vic. Thanks for that. OChem question, drop it in, and if we have time, I'll add it. So the question now is currently Eagle's question here. Let's update that question now. So current topic is Fourier, and then the next one will be imaginary, but I haven't seen our friend ask about imaginary in some time, so it might be integration techniques, and it could be OChem question mark. All right, so if you have an OChem question, feel free to drop it in. We've got 25 more minutes left on the chat, and then I'll be ending it for today, but don't worry, I'll be back tomorrow. All right, so we have the Fourier series of g sub x equals absolute value of sine of x over 2 from 0 to 2 pi. Okay, and let me get the formula for Fourier series up. Fourier series formula. What class is this for? Are you taking I'm assuming you're taking like signals or process control, process dynamics, something like that. Okay, so which is the working formula I want to use? So the general equation is basically going to be, let's use this one here. F of x is equal to a naught plus the sum of n equals 1 to infinity of a sub n times cosine of pi times n times x divided by L. Or, my friend, do you have your own working equation whereby it would be more familiar to you, because maybe this is in a form that's a little bit more general. So let me know, Eagle, if it's going to be a different formula, but it should look something like this. Oh, this is Math 2 in Germany. Interesting. Okay. Very interesting. Glad to have you here. I live in the States, as you might have guessed. All right, so my first thought is, okay, if g of x equals sine of x over 2, and we want to find the Fourier sum of this, let's just go ahead and plot that real quick, just to have an idea. So we're going to just plot sine of x over 2. X divided by 2. Okay. All right, I'm having kind of like a brain fog moment. I'm not sure how to approach this one quite yet. So we need to get our A naught first. So we need to get our A naught, and then we can get A sub n times cosine of that term, and B sub n. So we effectively need our A naught. I'm kind of having a brain fog moment at the moment though. So I'm trying to think about if A naught is solvable from here. How can we acquire that? So A naught's going to be our first term in the series, right? Interesting. I might not be able to answer this on the live, Eagle. I'm going to have to drop this into Discord, and then I might have to just try this out. I don't think I'll be able to solve this live. First things first, though, we're going to have to solve for A naught. Okay, you're going to have to solve for A naught. And then solve for A sub n, because we need A naught, A sub n, and B sub n. And once we have that, then we can plug it in. But what are the formulas for those? What are the formulas? Yeah, I'm going to take a look at this. I'm going to drop it into Discord, and I'm going to take a look. If you want to DM me, I'll follow up. My question for you, is this a homework assignment or a exam test prep? Okay, let's see if we can just solve A sub n to get started. A sub n should be the integral of, well, the function sine of x over 2 dx from 0 to 2 pi. All right. So that's going to be 1 over pi, I believe. Okay. So, well, we should be able to get that. Just get the absolute value term is a sine of x, or rather cosine, a negative cosine of x on 2 times a 2, I believe, from 0 to 2 pi. I think it should be something like this. Let's see if we are able to plug these in. Derivative of cosine is sine. It's negative sine, so that's negative times 2. Cancel that out. Yeah, we should get that. So we evaluate that term as going to be negative cosine times so I'm effectively just doing this integral. So that's -2 times cosine of pi minus cosine of 0 should be a -1 minus a 1 4. This is going to be a 4. Okay, divided by pi. So tack on that pi. So everything is times 1 over pi. Okay, so we solved a sub n. Maybe we can do this. Maybe we can't do this today. Okay, so we got the first term is 4 over pi. Okay. And great. What's the next formula here? By chance, do you have the formula for a sub n for the sine term? The sine term and the cosine term. Let's get the formula here. Our professor is geeked. Homework, basically. Okay, got you. This is why chem is better. I got you on that problem, my friend. How to draw E, what is that? E4 bromopentane. We're gonna do that right after this. So for the sake of time, I think we're gonna just write down the formula. So you got the first term. We get the second term, a sub n. Okay, there should be another integral. Maybe you know what it is. Okay, it seems like it's gonna be, I just looked it up here, is gonna be a 1 over pi times the integral from -pi to pi times the function times cosine of n times x. So you're gonna have to review your trig now. So what is the trig formula for plugging that in? So the integral was sine of x over 2. So have fun with this integral. This is sine of x over 2 times sine of n times x. So there's going to be a trig identity to help you solve that one. Okay? So whatever you get, you're going to get some integer value for a sub n. And then b sub n, what's going to be b sub n? Let me just write down the formula for b sub n, and then I'm going to move on to the next person because I'm running out of time. Next person will be the person that asked about imaginary numbers. If that's still you and you're still here, comment okay to let me know that you're still here. And then the person that asked about integration techniques. And then finally, last question will be the OChem question from our friend. Is that, what character is that, my friend? E4 bromo pent 3n 1 all. And that's going to be a hard one as well. OChem is organic chem. OChem is organic chemistry. Okay, and then we're going to have 1 over pi times -pi to pi f of x times sine of n times x dx. All right, so we'll be plugging that guy in, -pi to pi. So our f of x was our sine of x term times another, no, sine of x over 2. Oh no, this is going to be times cosine, I believe. It should be times cosine, or did I get those wrong? Oh, this one is b sub n. Sorry about that. Make sure you correct that. The first one was b sub n. This one's a sub n. So the b sub n is a sine one. And then the b, and then the a sub n is a cosine term. And this one's going to be cosine n times x. Finals tomorrow on what, Lucas? How's this accent exams? This is not calculus 2 anymore, guys. This is more like calculus like applied. This is like applied math. This is like a little bit more advanced. You're not going to see this in Calc 2. Can't find it, but you stated to use the trig identity sine cosine equals 1/2 sine a plus b. There you go. So I'm going to ask you to either take a screenshot or you can DM me, and if you get stuck, just let me know. All right? And shoot me a DM. Okay? Oh, Calc 2 exams are going to ask you to do tests. Okay, Calc 2 exams are going to ask you to do tests. And they want to test if it's convergent or divergent. Okay? So this is not calculus 2. This was like a different question. Okay. So next topic is imaginary, but I haven't seen that person respond. So I think imaginary person is not here. So integration technique, let me know if you're here. Otherwise, next up will be OChem. And I see that the person that asked the OChem question is much more engaged. So we might skip that person if we see that they are still here. So you wanted to do, okay, you wanted to do, thank you for typing it again, really appreciate it. How to draw E4. What's your profile? I want to say, is that from Total Drama Island? Is it like trending that people make their profile from TDR? Or what is that? TDI. Okay, integration techniques. All right, so I'm gonna answer integration techniques, and then you're gonna be my last. You're gonna be my last one. All right. Yeah, I think it's from Total Drama Island, my friend. Okay, so integration techniques. Thank you, Vic. Thank you for responding. So we're gonna do 2 more questions for today, my friends. Thanks a lot for joining. Once again, my name is Dr. Drew. Got about 10 minutes left for today. If you missed the live stream, you can catch the replay on YouTube. I'll post later tonight. I'll be back tomorrow. And a couple more requests, integration techniques. Okay, so there's a couple integration techniques you need to know. And right off the bat, the most important one is U-sub, because pretty much all of them are technically U-subs in disguise. All right, so U-sub is going to be when we have a function within a function. So this is kind of like the equivalent of, it's the equivalent of chain rule in Calculus 1. So if we have a function within a function, for example, f of g of x dx, then that's going to be a hint that it might be a U-sub. Might be a U-sub. All right? So for example, if we have, you know, and then times another function. Times another function. H of x. Okay? So for instance, if we have, you know, 1 plus x cubed to the power of 3 over 2 times x squared, this is screaming at me that it's going to be a U-sub. Okay? So I see a function within a function. So I'm going to select my U to be 1 plus x cubed. Let me just do a quick check. How are we doing, chat? Okay, so far no questions. Let me know if there's any more questions. And the reason I did that is because when I differentiate du, I see that I get 3x squared. And that's dx. So now my derivative is now inside the integrand. Okay? So now everything is written in terms of u. So I can rewrite that nasty function into simply u to the power 3/2 times a 1/3 du. Okay? And solve that. That's going to be u to the power, you add 1, which is a 2/2, which should be a 5/2 times the reciprocal, which is a 2/5 times another 3 plus c. And just double check, that's true. 5/2 times 2/5 cancels out, that's 1/3 u to the power of 3/2. So that's going to be 2/15 times the power of, times 1 plus x to the power 3 to the power of 5/2 plus c. Okay, so I kind of just made up that integral in my head. And that's going to be the first technique, is u subs. Let me know if that made sense. Do you make a lot of money since you have a PhD in engineering? Well, that's a great question. Thank you, Eagle. Thanks for stopping by. All right, the next one is going to be integration by parts. And that was actually the first one we went over today. So again, I encourage you to watch the replay later today. So I'm just gonna go back. Integration by parts is similar because we're still gonna have a u and a dv. And you have to use the formula uv minus integral v du. So similarly, you're gonna select a u that is easily differentiable and a dv that is not terrible to integrate. So in this case, we had the integral of x squared times e to the x dx, and so u was x squared and dv was e to the x. Okay, so ultraviolet voodoo is the way to memorize uv minus integral v du. Okay, how do you identify u sub versus IBP? U sub is a function within a function. Integration by parts is a function times another function. Okay, so u sub is a function within a function. IBP is a function times another function. Usually not is not a function within a function. So for example, x squared times e to the x, I have x squared is one function, e to the x is my other function. And similarly, I have this one is x times cosine of x. It's not a u sub because I can't differentiate and then get something back. It has to be IBP because I have a function times another function. All right, so that's going to be IBP, x times cosine of x. So again, just watch the replay if you missed that. The last one that you need to do is trig subs. Last one is going to be trig subs. So I'm just going to tell you one of them is going to be dx over a squared plus x squared. So there's 3 trig subs you need. This is the first one. And the first one you're going to need is going to be, if you see something of the form that looks like the Pythagorean theorem, a squared plus b squared equals c squared, that's your hint that, and it's in the denominator. If you see a denominator that looks like the Pythagorean theorem, that's your hint that it's going to be a trig sub. All right, and I'm going to jump to the last question, my friend, because I'm running out of time. And you're going to select a to be, you're going to select x to be a tangent of theta. Okay, I have some videos on my channel where I go over trig subs. So just swipe right to my profile, click on the math playlist, and then scroll down until you see some trig subs, basically. All right. Anytime, Vic. And perfect. So we're on for our last question of the day. So I'm gonna write that down, and perfect. And so my Total Drama Island friend, it's finally your turn. Thank you for your patience. Thanks for copying it again. Appreciate you. So let's see, we have E. Okay, and I'm sorry to keep you waiting because nomenclature is not my strength. I'm not gonna front. Nomenclature is not my strength at all. So I'm gonna get started. I'm gonna help you get started on it, but I'm not gonna lie, it's not my strength. So I see bromo, pent, so I'm gonna see pent first. I'm gonna help you get started on it, and then I'm gonna chime in with my Discord and see what they say. So I'm gonna say 1, 2, 3. Pent is 5. So I'm gonna say 1, 2, 3, 4, 5. And then I see 4. So I'm gonna label this as 1, 2, 3, 4, 5. So I see 4 bromo. So I'm gonna put 4 bromo right here. Pent 3 ene. So then I see 3 ene. So I think my 3 ene is gonna be here. It doesn't say which is the ene though. 1 all, and then I'm gonna put a 1 all right here. So I think it's this. I think it's this question mark, but again, I'm not gonna front. Nomenclature is not my cup of tea. So I'm gonna take a screenshot of this, drop this in the Discord, and then see if my people see if people agree or disagree. This is my first guess, so please take this with a grain of salt. Guys, unfortunately, I do have to end it here. I put on the 3rd to 4th comment, but I'm not sure. Yeah, that's kind of what I'm debating as well. So is it this one or is it this? Let's debate it in the Discord. So guys, I gotta end it, but don't worry, I will be back tomorrow. Okay, right around the same time. Okay, I'm gonna put this on the 3, 4. That's a great question. I'm gonna drop it in the Discord. Guys, thank you so much for joining. If you want to join the Discord, it's 100% free. Go to engineeringminds.co or tap that link in bio or just shoot me a DM. Guys, if you have any questions for OChem, Gen Chem, math, or physics, I got you covered. Once again, my name is Dr. Drew. Thank you so much for joining. I will be back tomorrow. The Discord is 100% free. We have videos and practice problems and everything you might need for your STEM journey. And guys, once again, my name is Dr. Drew. I got you covered on various STEM subjects. So if you need any tutoring for math, Gen Chem, OChem, physics, sign up for a free consultation. Call my friends. I will see you tomorrow. And peace out, my friends. Super appreciate y'all's time. Have a great rest of your evening. You helped me make 100. Oh, BDR got 100. Taking AP Chem final tomorrow. Good luck, Jose. Good luck. I hope you cook it. I think you're gonna cook it. And my friend, Total Drama Island, profile picture. I don't know your name. Heart Wave. What is that? Heart Wave Coconut. Heart Wave Cocoa. If you shoot me a DM, I'll get back to you with the solution. Hopefully that will be right. So shoot me a DM and then I'll get back to you with the correct answer by tomorrow. All right, peace out, my friends. Have a great rest of your night. See you tomorrow.